One of the simplest and most common failure detection mechanisms is the heartbeat. In this model, a healthy node periodically sends a small message, a heartbeat, to another node or a central monitor. If the receiving entity does not receive a heartbeat within a predefined timeout threshold, it assumes the sending node has failed. This sender-receiver model is straightforward to implement, but it has limitations. A single point of failure in the monitor or network issues between the sender and receiver can lead to false positives. However, heartbeats provide a foundational level of liveness detection, signaling that a node is still operational and responsive. For larger, more dynamic, distributed systems, centralized heartbeat monitors can become bottlenecks or single points of failure. This is where gossip protocols, also known as epidemic protocols, shine. They offer a decentralized approach to failure detection. Each node periodically exchanges information about the liveness of other nodes with a small, randomly chosen subset of its peers. This gossip information, including timestamps of when nodes were last seen alive, propagates throughout the network like a rumor. If a node consistently hears that another node hasn't been seen alive by its peers for a certain duration, it can infer a failure. This peer-to-peer communication ensures faster detection in large systems and is highly resilient to individual node failures. Beyond just detecting failures, distributed systems need mechanisms to ensure data consistency and availability even when nodes are down. Quorum-based approaches are fundamental here. A quorum refers to a minimum number of replicas that must agree on an operation, read or write, before it can be considered successful. For example, a write quorum, W, dictates how many replicas must acknowledge a write before it's deemed committed. A read quorum, R, specifies how many replicas must be queried to ensure the most up-to-date data is retrieved. The key to consistency and fault tolerance is ensuring that R plus W is greater than N, where N is the total number of replicas. This majority vote principle guarantees that any read quorum will overlap with any write quorum, preventing stale reads.